All right, let's continue with another graph. This time we're going to do a cosine function. Okay, we're going to graph a cosine function. We're going to write all the components of that. All right, so this is the equation that we have. The function that we have is right here. And notice that it's written as a cosine function, and also notice that the way it's written you have to pay attention to. Now, does this look like the standard form of the transformation? Now notice that in a standard form everything is really uniquely written and separated. Here we notice that this theta or x doesn't matter, so this theta is just an angle. It could be x in here, doesn't matter. So notice that x has to come first, but here x comes in the second term of the argument of the cosine. So we have to make this equation look like the standard form, and to do that you need to rewrite this equation so that it can look like the standard form. And to do that you have to isolate x, or in this case x has to come first. So to make it so that it comes first, two ways you can do this. Number one is that you can just simply do this: minus 2x plus pi over 2 minus 1. So I just switched them around, right? But then you notice that in here this coefficient in front of theta or x has to be 1, because this coefficient b has to be outside of that bracket. That means this 2 needs to be out here. All right, so we have to go ahead and factor that out. So it would be 2 cos of negative 2. So now I have taken the negative 2 outside, okay? And then let's go through, because I'm factoring negative 2 from both of these two terms. So factoring negative 2 out of minus 2x, that's x, and then minus, what do you have to multiply 2 by to get pi over 2? Well, that would be pi over 4. Okay, and if you're not quite sure, you have to play around with that, because 2 times pi over 4, that's pi over 2, and negative makes it a positive, so that's what we got, and that's minus 1. That is now written in a standard form where you can apply all the transformation to that. This is a very, very important step. If you don't do this, you will not be able to graph this properly. Okay, remember, you're graphing this freestyle. Okay, so here are the components of the function. First, the 2 in front right here, that's the leading coefficient, that's your amplitude, so absolute value of that's just 2. Very good. The vertical is stretched by a factor of 2. The period of the function comes from the 2 here. Okay, it's negative 2. Okay, that's fine, but really you're taking the positive value of that. So that's the period of the function. So notice that the graph has been compressed horizontally by a factor of half. Great. And then notice that this negative, so this negative right there is the same negative there. Okay, that negative means that the graph is being reflected over the y-axis. Good. The next piece is the negative pi over 4. Negative pi over 4 is the pi over 4 shift to the right. That's what happens, is a horizontal shift. The vertical shift is the very end, negative 1. That means the graph drops down by 1. And then the equation of the midline is y equal to negative 1. All right, now we're going to go ahead and graph this. And this time, we're not going to graph it the same as what we did with this sine, but we're going to do one part at a time, and then we're going to put it together. Okay, so this is now the original parent function of y equal to cos x, okay? And this is the red graph. Now we want to graph this transform function. So we're going to do one step at a time. Again, order of transformation. The 2 starts first, and you know that. So all these y coordinates that you see, you get stretched out by a factor of 2, and we've done this before with the sine, and you know what is happening. So that point drops down, this point goes up, everything stretches, and if I click on that, you see that some of the coordinates is there. I did go ahead and included negative pi over 2 as well. So you can notice that the graph can go left and right. Just for the simplicity's sake and something different, I try to graph the negative part of the x values as well, so that you can see it. All right, but the same idea, everything has been stretched vertically. The next piece we have to deal with is the -2, but this negative in front, that's a reflection over the y-axis. But here is the thing, if you flip this point pi over 2, flip it over to negative pi over 2, and then negative pi over 2 flips over to pi over 2, it maps itself. So all of these points are symmetric points on a line, and a symmetric line of y-axis. So it's not going to change anything. So to prove that to you is that if you graph this again, so I'm going to click on that and notice that the blue graph is the same as the red graph. So that's why one of the reasons we call cosine functions an even function, because the negative value of the angle doesn't really change the graph. Okay, so for that matter, nothing changes. Okay, so the horizontal or the reflection over the y-axis, that doesn't do anything to our graph. All points map. The next piece is the 2, and the 2 is the horizontal compression. Well, remember the period of the function going from being pi, so here we go, negative pi to pi, this distance here, that's 2 pi. It should give us pi when we basically compress the value, the horizontal value, by half. That means all of these x value, y values will be the same. We're just going to halve the x values for the same y values. And when I graph that one, notice that it will happen. Everything changes. So now from here, negative pi to pi, it goes from negative pi over 2 to pi over 2. And the reason I unclicked the first part is because of both of them are same color. I don't want to confuse you, but same idea. That's the graph that you're going to get. Okay, so that's just a typical graph, and it's been kind of compressed now. Very good. And then the next piece of that is the negative pi over 4. That means every point is going to move to the right by pi over 4, and that means 0 becomes 0 plus pi over 4, negative pi over 2 becomes negative pi over 2 plus pi over 4. So this point is going to move to the negative pi over 4. This point is going to move to the pi over 4. This point is going to move to pi over 2. Everything is going to shift. And when I click on that, it should show you the shift. Here it is. That's the blue part, blue points. Okay. And the last piece is the -1. That means everything is now dropping down. So this coordinate here, where is negative pi and -2, becomes negative pi over 4 and -3. Okay, and then just continues like that. So if I engage the new points, and notice that it will happen, the green points are the new transform points, and you can continue with this. Obviously I'm just showing you one portion of this graph, but then if I go ahead and actually do the final graph, but if you go ahead and graph the function, now notice that I have changed this function. My bracket was misplaced. The bracket, originally I had it here. That's not correct. I had to be in front of the -1. So when I click on that, it should go through the green points, and it does. Then realize that the equation of the midline, it is your y equal to -1. The amplitude is still 2. The period has changed to pi, and basically it. And of course, all of your x-intercepts, they have changed. Now these x-intercepts are not, they are based on pi over 4, so this point here pi over 12, and these point is pi over 12, and there is a way of getting these x-intercepts, solving equations, trigonometric equations, but we'll do that for next sections. Okay, hopefully this helped you. Between this question and the last question, I need you guys to do a lot of examples so that you can get a hang of this. Okay.